Hello. In this session, I will be explaining about how to easily solve the Karnaugh map, which is normally used for designing digital circuits in the electronics industry. So whenever you are given a problem in the beginning, first check how many variables you need to deal with. It may be 2 variables, 3 variables, or sometimes even 4 variables. Depending upon the number of variables, the complexity also will increase. So after deciding how many variables you are going to deal with, first draw the checker box for corresponding variable. So if you have 2 variables, then the number of boxes you need to have is 4. If you have 3 variables, then the number of boxes you need to have is 8. If you have 4 variables, the number of boxes you need to have is 16. So the general formula you can have is 2 power 2. Depending upon the number of variables, if it is 3, then it is going to be 3 power 2, 2 power 3, 2 power 4, 2 power 5, and so on. So say for example, we are dealing with a 3 variable system. So the number of boxes you are going to have is 2 power 3, which is equivalent to 8. Draw the box first. After drawing the box, you need to position the variable in the box. Say for example, A, B, C are the 3 variables. You draw the line in the corner, and 2 variables can be assigned in the topmost portion, and another variable can be assigned in the bottom portion. AB can be assigned in the top half and C can be assigned in the bottom half. In addition, now there are 4 options for you if you deal with 2 variables A and B to have the bit positions. It may be 0, 0, 0, 1, 1, 0, 1, 1. So in top of all the 4 columns, you can write 0, 0, 0, 1, 1, 0 and 1, 1. Again, there is a small change. As per Karnaugh map, you can have only 1 bit change per position. So what we are going to slightly modify here is, first we are going to have 0, 0, 0, 1, then 1, 1 and finally 1, 0. There will not be any problem in assigning the bit position for the variable C, and as usual you can have 0 and 1 because you will be having only 2 rows because it is a 8 checkerbox system. After framing the bit positions, you need to write the number position for all the boxes. So for this you have to take all 3 variables into account. So A, B, C, it will start from 0, 0, 0 to 1, 1, 1. So it will come from 0 to 7. So based on the positions of your numbers, you fill all the boxes with numbers 0, 1, 2, 3, 4, 5, 6, 7. After entering the numbers, you go to your problem given and find out how many numbers is given in your question. Say for example, if it is only 3 numbers and 4 numbers, come back to your checker box, erase all the other numbers, and wherever you find the number in the question, replace it with 1. So now these are the boxes which we are going to deal with. The next step in the Karnaugh map we are going to do is we are going to match or combine the adjacent cells. So first you must know what you mean by an adjacent cell. Any cell which is closer to the next one can be called as an adjacent cell. It can be in a row wise fashion or it can be in a column wise fashion. The third option you can have is all the 4 corner boxes. These are also called as adjacent cells. So with all these adjacent cells we are going to do the combining process. So combining is done in such a way that we are going to reduce the number of terms or the variables in the digital circuit. So how can you do that? First go and see whether you can combine in terms of 8, because the maximum possible availability for you is only 8 boxes. If all 8 ones are there, you can combine at a stretch. If not, go and check for combination in terms of 4s. Even if it is not available, you can go for combinations of 2s. But you have to combine everything at least one time per cell. So now when you go for combination of 2 cells or 4 cells, you can have their corresponding positions written separately, and wherever you have different bit numbers, say for example 0s and 1s are repeated in a column, you strike it out. And all the numbers, say for example A and B are there, you have 0, 0, 0, 1, 0, 1 and 0, 0. If you find A, all are zeros, but if you find B, zeros and ones are repeated. So you take only the corresponding numbers which are same, and if it is 0 you can have it as A bar, or if it is 1 you can have it as A. The same thing applied for all the cases. So likewise you can go for combinations of 4s or 8s, whatever it may be. When you finally have the terms, you have the plus sign in between them, say for example AB plus C plus A bar, something like that, right? However, if you find the final terms, definitely after combination, the number of terms you have in your output will be very much lesser than what you have in the question or in the input. So this way of reduction helps in eliminating the number of gates used for practical implementation in digital circuits. The efficiency will be increased, the memory requirement can be reduced, the expensive nature of the circuit can be reduced, and most importantly, the circuit system will become much more simpler, which is very much essential for any practical applications.